Good morning, sixth graders. Today we are going to talk about how molecules move in a solid. Now we've talked about, or we've demonstrated and discussed how molecules move at different speeds in liquids, at different temperatures, right? We talked about how water molecules move, they're always in motion, but they move kind of close together and they wiggle just a little bit when they are in cold water. And when they're in hot water, they expand and they're further apart and they're moving really, really rapidly and they take up more space. Okay, so that concept is why water or the alcohol in an alcohol thermometer goes up when it's heated, right? There's that tiny little tube that goes all the way up the thermometer, and the molecules, when they are heated, move further apart from each other. They expand, and the liquid then takes up more space, and the liquid will move up the tube. There's a lot of similar things that happen in a solid. I'm going to have to show you a few animations because I can't take a solid and zoom in and show you that. So we'll have to rely on some animations. We'll start with the particles of a solid. Okay, so I'll play this and we see a big metal object here. We can zoom in and you might notice a few differences between these molecules moving in a solid and how they move in a liquid, right? The liquid, these molecules weren't just vibrating kind of in place. They were moving past each other, and here they stay fairly aligned. And that makes sense, right? Water, it will morph into the shape of whatever container you put it in, right? I could put water in a cube container and it will take on that shape. I could pour water into a graduated cylinder. It's going to take up that shape or take on that shape. But a solid is a solid. The molecules aren't going to change shape in a solid state, right? If you melted it, if you liquefied it, it could change shape and these molecules would slip by each other. But a solid, the molecules are still moving, but they stay in alignment. All right, let's compare molecules of a solid and in a liquid. Okay, again, here is an image of molecules moving. They're vibrating, but they're not moving past each other. They're not changing their shape. And in a liquid, they do. They're moving, but they also move past each other. They don't stay in the same spot. If you watch one of these, it can travel all the way across the screen over time. Okay? The first question says, how is the motion of the atoms in a solid metal different from the motion of molecules in liquid water? All right, so again, we're going through what is the difference between a solid and a liquid? How can you describe that? How does the motion of these molecules differ in a solid and in a liquid? Okay, next question. What is it about atoms and molecules in liquids and solids that keep them close to one another even though they are moving? Okay, so we kind of have to think back to that very first lab we did up with the wax paper and the water, right? Why do water molecules want to stick together? Think of a magnet. Okay, they're not magnetic, but they are attracted to each other in some way. All right? We've got a demonstration here. I'm going to show you the video of that. At room temperature, a metal ball fit through the ring. What happened when your teacher tried to push the heated ball through the ring? Okay, so I don't have one of those. I used to, but Mr. O'Peely and I just can't find it this year. So we're going to watch a demonstration about this. All right, so we'll go to full screen. What we're seeing here is that ball fits through the ring, and after the ball is heated up, so we've heated up those particles, it will not fit through. almost does, but it is expanded just a little bit. Now he's putting the ball into cool water to cool it, and sure enough, those molecules are going to condense back, huddle back together, and take up less space. All right, so looking back at this question, at room temperature, the metal ball fit through the ring. What happened when your teacher tried to push the heated ball through the ring? Well, what happened to these molecules? Why did it not fit? That's what number 4 is about. What happened to the atoms in the heated ball so that it wouldn't fit through? And after the ball was cooled by water, why do you think it will fit through the ring again? Okay, use what you've learned about how molecules move in different temperatures. All right, it says, you saw in animation that atoms in a solid move faster and get slightly further apart when heated. Well, you haven't seen that yet, but I'll show it to you right now. All right, we'll go to full screen. All right, here's our solid object again. Molecules are vibrating, they're staying in alignment. If I heat it up, they are moving a little more rapidly. Do you notice that they are getting a little slightly further apart, right? That would explain why that ball wouldn't fit through the ring. If the molecules expand, they get a little bit bigger. Now what happens if I continue to heat this up? Will this metal object eventually melt? It could. You know, if we kept cranking up the heat, these molecules would eventually slip past each other just like they do in a liquid, and this object could liquefy. All right, so draw a model of the atoms in the metal ball at room temperature and after it has been heated. Use circles and motion lines to show the speed and spacing of the atoms at room temperature. Include captions like atoms are faster and further apart or atoms are slower and closer together. All right, so at room temperature, are the atoms faster and further apart or are they slower and closer together? And then in hot, are the atoms of the ball faster and further apart or are they slower and closer together? And again, if you can't write on this Google Doc, go ahead and write on a regular piece of paper and then just take a picture and upload it with your assignment. The last question here. Look at the picture of the road. Look at the picture of the road of a bridge. Road and a bridge, I think I meant to say. The road on a bridge gets colder in the winter and hotter in the summer than the road leading to it and away from it. Many bridges have a flexible connection like the one shown in the picture. Knowing what you know about how solids act when they are heated and cooled, why do you think they put flexible connections in the road on top of a bridge? Why do you think that is? Think about that. Think about how what we learned here would apply to this real life situation. All right. Answer your questions here. Go ahead and turn that in, and I will talk to you soon.